January 1944, a frozen morning at the Luftwaffe's Rechlin test center. The hangar doors slide open with a metallic groan, revealing a shape that does not belong to the Reich. Frost clings to the wings of a captured P-51 Mustang, its olive-drab skin now marked with crude black crosses painted overnight by ground crews who still refuse to touch it longer than necessary. The air smells of cold fuel and burning heater carts. Mechanics stand back in silence. A German test pilot, gloved, rigid, aware of the irony, walks toward the aircraft that has been cutting down his comrades across the Reich. He pauses beneath the nose, studying the Packard Merlin intake, knowing its high-altitude power curve has already rewritten the air war. He climbs in. The cockpit is foreign, American dials, unfamiliar ergonomics, but everything built for speed, reach, and lethal simplicity. It carried external fuel tanks that stretched its range past what any Luftwaffe pilot considered reasonable for a single-engine fighter. For the first time, the bombers were not arriving alone. They brought a fast, agile escort capable of dictating the fight long before German units formed up for an attack. Inside Germany, this development forced a shift in priorities. The Luftwaffe High Command had to know what made this aircraft so effective. Intelligence units tracked crashed Allied fighters with a level of urgency that reflected the growing desperation. Whenever a machine landed relatively intact, whether through mechanical failure, navigational error, or combat damage, it became a critical asset. The Reich test centers, especially Rechlin and the clandestine KG-200 program, had long examined captured aircraft. But the Mustang demanded particular scrutiny. Early encounters showed German pilots losing altitude advantage, losing energy control, and increasingly losing their lives. Technical officers studied intercepted reports and listened to interrogation transcripts from downed Allied airmen. They saw patterns, Mustang formations arriving earlier than radar expected, holding altitude longer than Bf-109s, and climbing out of combat zones where FW-190s began to fade. Reconnaissance photos showed their extended penetration routes. Factory intelligence hinted at high production quality and rapid scaling potential in the United States. On the ground, maintenance crews examined downed Mustangs with a mix of frustration and respect. They noted the clean aerodynamic surfaces, the rational placement of access panels, the robustness of the radiator system that simultaneously cooled the engine and reduced drag. They saw a machine optimized for long-duration combat, not short, intense scrambles like German interceptors were forced into by fuel constraints. By late 1943 and early 1944, the Luftwaffe understood that the P-51 was no longer an interesting design, it was a strategic threat. Gaining access to a flyable example became a priority. When one finally arrived in recoverable condition, it triggered the test sequence that would soon yield a report so blunt that it passed through Luftwaffe channels with a mix of disbelief and resignation. That report, and the flight that produced it, were rooted in the conditions of a Germany struggling to retain control of its own airspace, a struggle that forms the essential backdrop for the next phase of this story. When the Luftwaffe finally secured a flyable P-51B, it arrived as both an intelligence asset and an omen. The aircraft had force-landed with damage that German mechanics could repair. Its radio was stripped, its weapons disabled. But its frame, engine, and controls remained viable. Rechlin's engineers moved quickly. The test center's mission had always been to understand enemy technology at a granular level, handling characteristics, performance envelope, structural weaknesses, and any exploitable flaw that frontline pilots could use. The first task was to document the aircraft's construction. German engineers crawled across the Mustang's wings, measuring thickness, checking surface finish, and studying the laminar flow contour that differed sharply from the more traditional Luftwaffe designs. They found tolerances tight and manufacturing consistent. Rivet lines were cleaner than those on late-war German fighters, where dispersed production and Allied bombing had degraded machining quality. The Mustang's radiator system, positioned beneath the belly, caught their particular attention. Allied engineers had paired aerodynamic efficiency with thermal management in a way Germany could not easily replicate under wartime constraints. Engineers then evaluated the Packard Merlin V1650 engine. The Germans already respected the British Merlin series, but the American-built version surprised them with reliability across the throttle range. The two-stage supercharger maintained stable boost at altitudes where Daimler-Benz engines began to lose their edge. The smooth delivery of power impressed the technicians who had spent months tuning and retuning German engines suffering from fuel inconsistency and part shortages. This power plant, they concluded, offered sustained high-altitude dominance without the fragility creeping into the Luftwaffe's own late-war inventory. Only after ground inspection concluded was the aircraft cleared for flight testing. A senior test pilot, trained to evaluate enemy aircraft dispassionately, prepared for the sortie. His role was not combat simulation but precise measurement, climb rate, roll characteristics, stall behavior, energy retention, dive stability, and high-altitude performance. The Mustang responded with a balance he did not expect. The controls remained firm at speed. The aircraft retained energy in climbs where a Bf-109G would begin to sag. Its dive stability rivaled the FW-190, yet without the compressibility issues that plagued German fighters at transonic descent speeds. The pilot noted that at 25,000 feet, where many Luftwaffe interceptors began to operate at the margin of their performance capability, the P-51 still behaved like a fighter with reserves. He realized that German tactics, vertical attacks, shallow climbs, slashing strikes, depended on achieving positional advantage early. The Mustang's ability to close gaps from below or extend them above meant those tactics were becoming unreliable. It was the first hint of what frontline pilots had been reporting. Engagements were no longer predictable. The enemy could chase, disengage, or re-engage at will. The second flight involved comparative maneuvers against German fighters. A Bf-109G and an FW-190A flew parallel test profiles, allowing the pilot to gauge how the Mustang responded relative to familiar aircraft. He watched the German fighters struggle to maintain coordinated turns at altitude while the P-51 sustained smooth arcs with less energy bleed. In dives, the Mustang accelerated quickly but maintained controllability deep into the descent, creating a margin of safety German pilots rarely enjoyed. In extended climbs, its performance remained stable long after the German aircraft began to lose steam. When the pilot landed, his written assessment was concise. The Mustang's combination of speed, range, altitude performance, and energy retention left German fighters at a tactical disadvantage in almost every realistic engagement profile. He recorded a line that circulated quietly through Luftwaffe channels. In combat conditions, this aircraft cannot be intercepted by our current fighters. Pilots paraphrased it into a darker phrase. It cannot be shot down, an expression of frustration rather than literal invulnerability, but one reflecting a strategic truth. This conclusion shaped thinking within both the technical staff and operational commands. The Luftwaffe now faced an aircraft that undermined its defensive doctrine at a fundamental level. Understanding this shift demands a broader examination of the angles, human, tactical, technological, and strategic, that define Germany's confrontation with the Mustang's rise. The first angle surfaced in the reactions of the men who flew and fought against the Mustang. Luftwaffe pilots were trained to exploit altitude, engine power, and decisive bursts of aggression. Their confidence, built during the early war years, relied on knowing the strengths and limits of their own machines. Facing the P-51 eroded that certainty. Reports from Jagdgeschwader units described engagements where German fighters initiated attacks from superior altitude only to find the Mustang climbing after them with unexpected endurance. Younger German pilots, many with fewer than 100 flight hours, found themselves overwhelmed by an enemy aircraft whose performance invalidated the limited tactical playbook they had been taught. For veterans, the shock carried a different tone. They understood how small advantages in speed, dive stability, or altitude translated into survival. To see an enemy aircraft hold those advantages simultaneously created a sense of inevitability they rarely admitted openly. Fighter Gruppenkommandeur wrote internal notes acknowledging that new Allied escorts displayed persistent presence, a phrase that captured the feeling of being unable to shake pursuit or dictate separation. The psychological effect mattered as much as the technical one. It shaped decision-making in the cockpit and altered risk calculations. A Luftwaffe pilot entering combat with reduced confidence was already operating at a deficit. The second angle involved the tactical disruption caused by the Mustang's range and climb performance. German air defenses depended on layered interception. Radar detected incoming raids. Controllers scrambled fighters to gain early altitude. Units formed up in climbing arcs to attack bombers before they reached primary targets. This system relied on precise timing and the assumption that Allied escorts could not maintain continuous coverage deep inside Germany. The P-51 nullified this. Now, Allied fighters were present throughout the mission. They arrived early, remained at altitude, and met German formations long before they could organize into effective attack groups. The Mustang also challenged German hit-and-run tactics. Interceptors typically executed steep diving attacks, firing a short burst before pulling away and climbing back to altitude. Against earlier Allied escorts, this had been effective, but the P-51 matched or exceeded German acceleration in the dive and could climb back with enough energy to interrupt the reset cycle. Interception groups found themselves scattered and forced into defensive maneuvers before ever reaching bomber formations. Mission logs reflected increasing failures to coordinate massed attacks, reducing the Luftwaffe's lethality at the moment it could least afford in efficiency. The third angle focused on engineering. German designers recognized that the Mustang embodied a philosophy they could not replicate under bombing pressure: industrial consistency, strategic foresight, and tolerance for long-range operations. The laminar flow wing reduced drag, but required manufacturing precision impossible in dispersed German factories, fragmented by Allied attacks. The radiator duct's Meredith effect returned thrust by expelling heated air efficiently, something German engineers admired, but lacked the resources to integrate into new designs. The Packard Merlin's high-altitude power curve stood out. Its two-stage supercharger maintained output where German engines dipped. This allowed the Mustang to retain performance in the exact band, 20,000 to 30,000 feet, where German interceptors needed superiority to protect the Reich. German test pilots noted that even when the P-51 carried external fuel tanks, its agility remained acceptable. Once the tanks were jettisoned, it became a high-performance fighter without endurance penalties. It was the combination, range, altitude, speed, and stability, that created a threat German engineers could not counter with incremental upgrades to the Bf-109 or FW-190. These angles form the initial structure of understanding that Germany developed from testing the captured Mustang. They lead into the remaining strategic, enemy, and moral dimensions that completed the Luftwaffe's assessment of an aircraft reshaping the war. Luftwaffe leadership absorbed the Mustang's implications faster than many frontline pilots. By late 1943, strategic planners within the Reich's Luftfahrt Ministerial were already confronting an unavoidable conclusion: the defensive model built around short-range, high-performance interceptors was collapsing. Jagdgeschwader commanders filed reports describing the inability to mass fighters without immediate disruption from long-range escorts. Senior officers noted that pilot training programs were producing aviators unsuited for prolonged, energy-intensive dogfights. The Mustang intensified these deficiencies. Even skilled pilots could not compensate for machines strained by fuel shortages, material inconsistencies, and rushed field repairs. High Command attempted responses, deploying improved Bf-109G variants, pushing the FW-190 into higher altitude roles, and accelerating the FW-190D and TA-152 programs, but none addressed the fundamental problem. Germany had no long-range fighter capable of shaping engagements on its terms. Leaders who examined the captured P-51 understood that they were facing an aircraft designed within an industrial ecosystem Germany no longer possessed. The test report's grim assessment reinforced what situational analysis already indicated. The Luftwaffe was entering a phase where technical disadvantages could not be offset by tactical ingenuity. From the enemy's perspective, the P-51 served as the instrument that finally gave the USAAF operational reach. With the Mustang, bomber streams no longer accepted the attrition that had defined deep penetration raids in 1943. Escorting fighters arrived over targets with fuel reserves and combat strength intact. They disrupted German assembly zones, attacked airfields, and patrolled likely intercept points. This changed the geometry of every mission. Luftwaffe units attempting to climb into position encountered enemy fighters already waiting above them. German pilots who faced Mustangs repeatedly reported that the Americans now fought with strategic confidence. They avoided unnecessary duels, struck only when advantageous, and maintained cohesion across long distances. The Mustang magnified this discipline. It allowed escort groups to sweep ahead, clearing approach paths and isolating German units. The effect resembled a gradual tightening of an operational noose. Every week, fewer German formations reached the bombers. Every week, more were intercepted before reaching altitude. This erosion of airspace control defined the enemy angle, the shift from contested skies to an environment increasingly governed by Allied reach. The final angle emerged from the deeper moral and structural forces behind the confrontation. The Mustang represented more than a machine. It signaled the industrial and logistical asymmetry that was now determining the war's outcome. German test pilots examining the P-51 confronted not only an advanced aircraft, but the reality that Allied industry could produce thousands more. They recognized that no incremental upgrade to existing German fighters would restore balance. Even projects like the Me-262 or TA-152 faced shortages of alloys, fuel, and trained pilots. The Mustang required none of these compromises. It arrived in quantity, operated reliably, and demonstrated consistent performance across seasons and mission types. This moral angle, the recognition of inevitability, surfaced in private diaries, briefing notes, and after-action reflections. Pilots wrote about entering combat knowing that the enemy possessed a tool built with resources their own country could no longer match. Confidence eroded, not only because the enemy flew a better aircraft, but because that aircraft symbolized a broader collapse of strategic possibilities. The test flights at Rechlin confirmed what many already sensed. The Luftwaffe was losing the ability to shape the war in the air. These angles complete the analytical framework, setting the stage for the decisive moment, the turning point where the German evaluation of the Mustang intersected with the broader collapse of the Reich's aerial defenses. The decisive moment emerged during a sequence of controlled test flights designed to map the Mustang's full performance range against the Luftwaffe's best available fighters. These were not demonstrations for propaganda or morale. They were methodical evaluations conducted by engineers and pilots who understood that the future of Germany's air defense hinged on accurate, unfiltered data. The P-51B was flown through climb profiles, high-altitude circuits, dive runs, and turning maneuvers with an intensity reserved only for machines capable of altering the strategic balance. The first critical test focused on altitude performance. The Mustang was brought to 25,000 feet, then pushed past 30,000, sustaining power delivery through the stages of its supercharger, with a smoothness that German pilots noted immediately. The Bf-109G, flown alongside in a comparative profile, began to lose climb efficiency long before the Mustang showed strain. The Mustang's acceleration at high altitude resembled what German pilots expected only from clean, low-fuel conditions in their own aircraft. The test pilot recorded that the P-51 retained combat initiative at altitudes where German fighters were forced into conservative energy management. This was the first turning point. Altitude, once the Luftwaffe's primary advantage, was no longer guaranteed. Next came the roll and turn rate assessment. The Mustang's wide-track landing gear and stable aileron response gave it predictable handling across speed ranges. In medium-speed turns, the P-51 bled less energy than the Bf-109, allowing it to sustain an engagement longer without dropping into a vulnerable low-power state. The FW-190A remained strong in roll rate, but lacked the high-altitude performance needed to remain competitive deep inside Germany. The German pilot noted that in a prolonged engagement, the P-51 would dictate angle and separation, an acknowledgement that positional control, the essence of air combat, was shifting away from the Luftwaffe. The next decisive test examined dive behavior. German fighters traditionally relied on dive superiority. The FW-190A especially could break contact by entering steep dives in which few Allied fighters could safely follow. When the P-51 was pushed into a high-speed descent, the test pilot found that it remained stable at velocities where German fighters approached compressibility limits. The Mustang held control authority deeper into the dive, enabling it to either pursue or disengage with a margin of safety unavailable to German pilots. This directly endangered the Luftwaffe's escape tactic. If an enemy could follow into the dive and then climb back out with more residual energy, it meant German fighters had lost their most reliable defensive maneuver. The most revealing moment occurred during the extended chase simulation. A German fighter initiated a climb to generate separation. The P-51, starting from a lower position, accelerated upward with a rate that contradicted long-standing assumptions. When the Mustang closed the gap, the German pilot realized that traditional altitude-based strategies could no longer guarantee survival. The test report described the Mustang's ability to pursue at will, a phrase that encapsulated the shift in control. The hunter no longer had to relinquish the initiative simply because the fight moved into a new altitude band. These controlled evaluations coincided with real combat events unfolding across Germany. During Big Week in February 1944, the USAAF launched sustained raids against German aviation industry targets. Mustang escorts accompanied the bombers all the way to Leipzig, Schweinfurt, Regensburg, and beyond. German formations attempting to mount intercepts encountered P-51s arriving early and in strength. Several Jagdgeschwader reported that their groups were hit during climb-out before forming into attack strength. The test pilot's findings matched frontline experience with disturbing accuracy. The Mustang retained energy, altitude, and initiative across every phase of the engagement. Individual combat reports reinforced the turning point. Pilots from JG-2, JG-3, and JG-11 described engagements where the P-51 outclimbed and outran interceptors even when the German fighters held positional advantage at the start. The Mustang's presence prevented mass attacks on bomber formations, fracturing the Luftwaffe's last effective method for inflicting heavy losses. In multiple engagements, German pilots found themselves forced defensive almost immediately, unable to execute the slashing dive attacks that had once formed the backbone of their interception doctrine. By the end of these combined test and combat experiences, the Luftwaffe possessed a clear, undeniable assessment. The P-51 was not simply an improved Allied fighter. It was the machine that removed Germany's final leverage in the air war. Once the Mustang demonstrated that it could neutralize German fighters at altitude, survive extended engagements, and return home with fuel to spare, the balance of air power tipped irreversibly. The next stage of the climax emerged from how these findings intersected with battlefield realities and the accelerating collapse of German air defense capacity. The second phase of the turning point unfolded as the Luftwaffe attempted to translate the test findings into tactical adjustments, while the strategic environment deteriorated around them. By spring 1944, German interception corridors, once organized, disciplined, and capable of mounting concentrated attacks, were collapsing under sustained pressure. The P-51 did not merely outperform German fighters, it dismantled the timing, geometry, and psychological foundation upon which the Luftwaffe's defensive doctrine depended. The first operational shock came when Jagdgeschwader units attempted to mass for interceptions during deep penetration raids. Radar operators tracked bomber streams, issued scramble orders, and directed fighters toward climb points. But as groups ascended, Mustang formations swept across approach paths, forcing German pilots into defensive breaks long before they reached attack altitude. Controllers reported losing cohesion among their own units within minutes of takeoff. The test report's prediction that the P-51 could engage at the moment of German assembly proved accurate. The Luftwaffe lost the ability to choose when or how to fight. The second shock emerged during repeated attempts to conduct vertical attacks on bomber formations. Traditionally, German fighters climbed above the bombers, rolled over, and executed high-speed diving passes. The tactic depended on altitude superiority and escape routes. By early 1944, the Mustang's presence denied both. Pilots initiating dives found P-51s descending with them, closing the gap during the recovery phase. Others attempting zoom climbs after attacking bombers discovered that the Mustang could shadow their ascent, forcing them to maneuver prematurely and lose the altitude necessary for a second pass. The interception model, attack, reset, attack again, died under the Mustang's ability to remain engaged across the full energy spectrum. Combat reports from JG-1 and JG-27 described the new reality with blunt clarity. Pilots wrote that once a Mustang entered the engagement area, contact could not be broken cleanly. The phrase echoed the Rechlin test pilot's finding. Even if not literally invulnerable, the Mustang could not be reliably disengaged from. German fighters that attempted to withdraw at low or medium altitude faced relentless pursuit. Those that dove risked being followed. Those that climbed lost momentum first. The Luftwaffe had no maneuver that consistently restored initiative. The turning point deepened as the Mustang began conducting aggressive forward sweeps. Instead of waiting near bomber formations, P-51 groups surged ahead to disrupt German assembly zones and attack airfields as fighters were forming on the runway. This preemptive pressure eliminated the last vestige of Luftwaffe tactical control. Combat diaries recorded entire Gruppen aborting missions after losing multiple aircraft before reaching operational altitude. The result was a collapse of unit cohesion, uneven pilot experience, and fractured command execution. Germany still possessed skilled individuals, but they could no longer fight as a coordinated force. Losses mounted. During the spring and summer of 1944, attrition among German fighter units accelerated to levels from which they could not recover. Mustang escorts destroyed aircraft in the air, caught others landing, and hunted stragglers returning from fuel-starved missions. Even the introduction of improved German variants, the Bf-19G6 with better armament, the FW-190A8 with upgraded power plants, and later the high-altitude Bf-19G14, failed to restore balance. None matched the Mustang's combination of altitude performance, endurance, and combat flexibility. The broader strategic environment amplified the effect. Germany's fuel crisis deepened, training hours for new pilots shrank, maintenance crews worked under bombing disruption, engines arrived with inconsistent tolerances. Under these constraints, the Luftwaffe needed an aircraft that could conserve energy, hold altitude, and re-engage without excessive fuel consumption. The Mustang, by contrast, arrived over targets with reserve capacity, a structural advantage Germany could not counter. Every engagement revealed the widening gap between an industrial superpower reaching its full potential and a nation fighting with diminishing resources. The climax reached its final form during missions supporting the Normandy landings. P-51s patrolled aggressively, struck communication lines, and maintained overwhelming air cover. German fighters attempting to intervene faced not only the same performance disadvantages identified at Rechlin, but also numerical inferiority created by relentless attrition. Overlord cemented the Luftwaffe's collapse. Even elite units such as JG-26 and JG-54 reported that they could no longer shape engagements. They fought only when forced, rarely with advantage, and increasingly without expectation of victory. By the time the German test evaluations circulated through command channels, their conclusion no longer described a future threat. It described the present reality. The air superiority contest had ended. The Mustang had become the instrument through which Allied air power rendered the Luftwaffe strategically irrelevant. This collapse sets the stage for the aftermath, where the consequences of the Mustang's dominance reshaped Germany's military, its industrial capacity, and the final year of the war. By mid-1944, the operational consequences of the Mustang's dominance were unmistakable. Luftwaffe units attempting to mount intercepts suffered mounting losses, both in aircraft and experienced pilots. Elite Gruppen that had survived the Eastern Front and earlier Allied raids found themselves confronting an enemy capable of dictating engagement terms. Mission reports described formations dissolving under Mustang pressure long before reaching bomber altitude. Pilots returned from sorties with fuel exhaustion, minor damage, and shattered morale. Some never returned at all. Losses compounded in a system already strained. Training programs for new pilots had been curtailed to save fuel and airframes. Instructors faced the impossible task of preparing recruits for encounters with aircraft the Luftwaffe could neither match in performance nor engage on equal terms. Aircraft attrition outpaced production. Replacement engines and airframes arrived sporadically and often incomplete. The combination of superior enemy machines, industrial capacity, and pilot depletion created a feedback loop that undermined operational readiness across the Reich. The Mustang's impact extended beyond immediate combat outcomes. Intelligence reports noted that Luftwaffe planners were forced to revise interception doctrine entirely. Attack altitudes, formation dispersal, and timing calculations were invalidated by the Mustang's ability to sustain energy at high altitude and follow German fighters through traditional escape maneuvers. Even innovations like late-model Bf-19G14s and Fw-190D variants could not compensate for the systematic advantages the Mustang delivered. Operational effectiveness declined across all units, with sorties increasingly failing to intercept bombers or protect industrial targets. The psychological impact on pilots and commanders reinforced these tactical losses. Diaries, debriefings, and intercepted communications reflected a pervasive acknowledgement that the Luftwaffe no longer controlled the skies. Reports described engagements where German pilots were outpaced and outclimbed at every phase, echoing the findings of Rechlin test flights. The Mustang's combination of range, high-altitude performance, and energy retention ensured that any attempt at a conventional interception now carried disproportionate risk, further eroding willingness to engage aggressively. Industrial strain and attrition were matched by strategic consequences. German airfields came under repeated harassment as P-51 sweeps extended beyond the bomber streams to cover approach corridors. Fuel shortages limited sortie frequency, and repair bottlenecks prevented rapid reintroduction of damaged aircraft. By the end of spring 1944, Luftwaffe operational capacity had diminished to the point where maintaining even minimal defensive coverage over industrial centers required exhausting every available asset, leaving other fronts exposed. The Mustang had not only proven superior in individual combat, it had redefined the conditions of German air operations. These cascading effects set the stage for the second part of the aftermath, where strategic collapse, quantitative losses, and the erosion of Luftwaffe capability became incontrovertible. By summer 1944, the full strategic consequences of Mustang superiority became apparent. Luftwaffe fighter units, already weakened by losses, faced impossible demands. The Normandy landings amplified the pressure. Allied air cover, dominated by Mustangs, allowed bomber and tactical aircraft to strike with near impunity. German formations attempting to intercept were caught in open air, often outnumbered and outmaneuvered. Combat reports from JG-26, JG-2, and JG-11 documented pilots forced into defensive maneuvers immediately upon takeoff, confirming that the operational environment had shifted irreversibly. Attrition accelerated. Experienced pilots, the backbone of Luftwaffe units, were replaced with recruits whose training had been truncated by fuel shortages and compressed flight hours. Aircraft losses outpaced production, and replacement engines and airframes were inconsistent due to Allied bombing campaigns against German factories. Even late-model aircraft like the Fw-190D or Bf-19G14 could not reverse the trend. Their marginal gains were nullified by the Mustang's superior energy retention, climb rate, and high-altitude handling. Numbers reflect the collapse. Luftwaffe sortie effectiveness dropped sharply. For every mission where German fighters intercepted Allied bombers, dozens of pilots were lost or aircraft damaged beyond immediate repair. Mustangs, operating at full range, engaged and withdrew repeatedly, inflicting continuous attrition while preserving their own operational integrity. This systemic imbalance contributed directly to the erosion of Germany's defensive air capabilities and facilitated Allied air supremacy over Western Europe. Beyond operational and numerical effects, the Mustang imposed psychological and doctrinal consequences. German command acknowledged that conventional interception strategies no longer worked. Pilots were operating under heightened risk, with reduced margin for error. Tactical adaptations, steep dives, rolling attacks, or altitude advantage maneuvers were neutralized by the Mustang's ability to match or exceed German aircraft performance across critical combat envelopes. The Luftwaffe's defensive doctrine was effectively obsolete. Strategic implications were equally severe. Key industrial centers, transport networks, and communication lines became increasingly vulnerable as air cover from Mustangs shielded Allied bombing campaigns. German leadership recognized that even the introduction of late-war jet fighters such as the Me-262 could not fully compensate for the systemic superiority demonstrated by the P-51. The evaluation of captured Mustangs had foreshadowed this collapse. The aircraft's combination of range, climb, and survivability was not a tactical anomaly, but a structural advantage that the Luftwaffe could not counter in the time remaining. The aftermath of Mustang dominance, therefore, was multidimensional: loss of air superiority, accelerated pilot and aircraft attrition, doctrinal obsolescence, and strategic vulnerability. This chain of consequences set the stage for the reflective closure, examining what the German evaluation of the P-51 revealed about industrial power, technological asymmetry, and the irreversible trajectory of the air war. The captured P-51 Mustang, evaluated by German test pilots, became more than a technical curiosity. It embodied the intersection of industrial capacity, engineering foresight, and strategic inevitability. In the cold calculations of Rechlin, the aircraft's performance revealed a fundamental truth. Germany's fighters could no longer dictate the terms of engagement. The declaration that the Mustang cannot be shot down was never literal. It was an acknowledgement that technological and operational asymmetry had rendered traditional German tactics ineffective. Energy retention, climb rate, and extended range combined to create an aircraft that consistently outmatched the Luftwaffe across the environments where it still had influence. The psychological weight of this realization shaped both pilots and command. Individual skill mattered less when machines dictated the energy envelope of every encounter. Doctrines, honed over years of combat experience, were suddenly insufficient. Even late war developments, the TA-152, the Me-262, could not offset the cumulative advantage of a systemically superior aircraft deployed in quantity. The Mustang symbolized a broader truth. In total war, industrial output, technological consistency, and strategic foresight often outweigh individual valor or tactical ingenuity. Historically, the evaluation of the Mustang crystallized the Luftwaffe's decline. It illustrated the limits of improvisation under resource scarcity and the consequences of losing the ability to control operational tempo. Allied air power, embodied in a single machine and amplified by production and doctrine, reshaped the European sky. The German pilot's report was not merely an observation of an aircraft. It was a testament to the shifting balance of power, a reflection on the interplay between technology and fate, and a reminder that in war, innovation and production often decide outcomes before the first shot is fired.